Let's take a look at some of the questions on the half sheet. So the first one says the graph of f is shown at the left and f equals the integral from 2 to x of g of t dt. What would the graph of g of x look like? Sketch it on the graph of f. So we first need to take the derivative using the fundamental theorem of calculus. So f prime of x is going to equal g of x. So now the question is really asking, what would the graph of f prime of x look like since f prime equals g of x? So this is the graph of f over here. It's increasing with a constant slope. So its derivative is going to be positive the entire time and constant. Any horizontal line above the x-axis would be a graph of f prime, which would be a graph of g. Second one, same graph, but now our integral has the x as the lower limit. So y'all know as we take the derivative, we have to flip those limits. So f prime is going to equal the negative of g of x. So in essence, this question is really asking, what would the graph of the negative of f prime of x look like? Since we know the graph of f prime, we drew it above, the graph of the negative of f prime of x is any horizontal line below the x-axis. Question 3 is asking the same thing, but now we have a different graph. But our integral is going to be the same as the problem 1. So taking the derivative, we get f prime equals g of x. So this question is asking us to sketch the graph of f prime. So now take a look at this function. We're sketching its derivative. So it starts with a slope of about 0. So the derivative is going to start about 0. F is concave up, so f prime will be increasing. And since f is increasing, f prime should be positive the whole time. Down here again, since we have the x as our lower limit, on number 4, f prime is going to equal the negative of g of x. So what would the graph of the negative of f prime of x look like? Well, just taking a look at the graph we drew from 3, the negative of that graph is going to be starting about 0, decreasing, and negative. Okay, you have another question to review like this one I wrote on the bottom of the page. So if we see a problem like this, either with secant to a power times tangent or cosecant to a power times cotangent, we're going to make u equal to cosecant. Our du is going to be negative cosecant x cotangent x dx. So now what we're going to do is we're going to go back up here to the integral, and we're going to borrow a cosecant from here to make it part of our du. So I'm going to rewrite the integral as cosecant squared times cosecant x cotangent x dx. This way I have everything I need for my du. So this is my du, and I just borrowed one of the cosecants from the cosecant cubed and moved it over here. So now in order to substitute, I just need a negative back here for my du, so that means I put a negative in front. So substituting in, I get negative u squared. Everything behind this becomes du. Okay, we just integrate using the power rule. So we get negative u cubed over 3 plus c. And then we're just going to plug back in. Negative cosecant x cubed over 3 plus c.